Hey everyone, I'm Marcus Galley. I'm an interaction design student at K3 in the master's program, and what I want to show you is basically going to be up on this projector, so I'm sorry you guys will have to turn around. But basically what I want to do is design a device to help people with disabilities. And so when I looked for a demographic, the demographic I want to basically target is a person like this who is vision impaired. You can see that he has a walking stick and a cell phone and this device around his neck that's like a braille reader. And so already there's a lot of technology and there's a lot of sort of like investigation and research done for devices for these people. Next slide. So how I want to build a device is I want to start using computer vision and depth perception. So this is an image taken with the Microsoft Kinect, and it's able to determine that there's this gentleman and that he's in fact closer based off depth perception than, of course, the things behind him. So in the image on the left, he's more red because he's closer to the camera, whereas the things that are far away fade from red to green and then finally to blue for the most distant things. So what that allows you to do is the computer now, for basically like, I don't know, $200 US, however much that is in crowns, you can get like a pretty accurate 3D representation on the computer of the real world. And if that's the case, then you can actually do a lot of analysis on this 3D information and come up with something that can assist people. So it's to the point where this is actually, well, not my project, this just shows how the technology can be used. This woman is actually moving her arm back and forth. The computer sees her arm, detects that it's in front of the wall behind her, realizes that there's actually joints in her arm, and then as she moves her arm around, this little bird acts as like a mechanical puppet. She can even open her hand, and the bird in the background that's being projected will open its mouth and actually like squawk like a bird. So this is just to show the fact that like in the real world, in real use scenarios, like this technology is advanced to the point where it could actually be used and isn't just something for the laboratory. So going back to this gentleman, basically what I focused on was this braille reader and the fact that there's a tactile sort of nomenclature already for people with vision impairments. So I figured I'd start with that and mix that with computer vision to come up with something. So this is a mobile device. It's quite small. It's actually quite wonderful. They're developed to the point where now they're very small, they're very lightweight, and compared to how they used to be, they're inexpensive. They used to be something like $20,000, $30,000 for these huge devices that you rest your whole computer on, and now they're sort of mobile and lightweight, and they're getting things like GPS, etc. So this is a rough example of the different types of technologies on the left that people are using for people with different disabilities, and on the right are the use qualities. So for instance, the top left corner you have electrostatic technologies. In the upper right-hand corner, what that gives to the finger to the touch is a sense of friction. But I looked at all these different things, looking at heat, looking at vibration, all these different types of things to see what would be the interaction I would like. And what I chose was to basically stick with the Braille nomenclature because that's something that's already been used and there's a lot of research in it. It's really well known. And so what I ended up doing was looking at the second thing, which is in red, which is piezoelectric, and the second thing on the right hand, which is normal indentation. So there are two possible solutions that I'm looking at. At the moment, there's this, which is a solenoid. It's basically a cylinder within a cylinder. You apply current, and the cylinder basically raises up. It's quite similar to these little Braille readers. The downside of these is that they're extremely expensive, they create a lot of heat, and they require a lot of electricity. So I've been trying to spend the past couple months sitting with this, trying to figure out how can I make this economically viable? How can I make it so that somebody could actually have this device and move and not have to have an extension cable so they're plugged into the wall all the time? Next slide. So what I've started to look at are these, and these are piezoelectric actuators, where basically there's this long rod and you apply current to it and it raises up. And because the rod raises up, it pushes these little pins upward. These actually are what are used in the Braille devices. They're relatively lightweight, but unfortunately they're still expensive. So they're lighter weight and they use less electricity, but they're less expensive. I would create a grid like this that would mimic the grid of pixels on a screen, but they would be touch pixels. Hopefully it would be lightweight like this handheld. This is an example of what one of these devices looks like. But just go to the next slide because I think it's described well enough. And then this is the exploration that I've been doing so far, which is to use the Kinect to determine that I'm invisible in the screen, that I'm in front of the wall behind me, and then to send that signal down to an array of LEDs. I'm using this array at the moment just because it's cheaper than to use all these other methods I've been talking about, but this is just to show the fact that the technology is possible, that I've already developed this half of it, and all I need to do is swap out the LEDs with actual a mechanical piece, and then I would actually have something. Thank you.
I'm telling you, it was 4:59 when you said thank you. Good timing. Thank you very much.
Thank you.
Please, time for the jury. It's you guys. Yeah.
Thank God. Technical terms ago.
Why did you focus on the visually impaired?
To be honest, I looked at a lot of the devices that are out there, and no offense to the people who have made them, they seem quite clunky. It's impressive what people are doing, and they're wanting to help those with disabilities, and so I don't want to speak negatively about that. I just felt that the devices so far are clunky, and I felt that that was maybe somewhere that, since I'm so focused on computer vision in my own time, and it's something that I'm constantly thinking about, I just felt that I could more readily come up with an answer that might actually be viable, and more than just a design concept that looks nice, but in reality is kind of like questionable. It's entirely possible that maybe something more for people with hearing impairments is more realistic, but it's just outside of the area of my expertise.
What's the vision like? What does it boil down to? Because I understand the technology part, but is there a product involved in this?
Yeah, so at the moment, there's one product that's a real-world product that can be purchased on the market, and it basically uses motion sensing. So it basically will shoot out a ray, hits a person, bounces back, like classic sonar stuff. And so what it allows the blind person to know is how far away objects are. So as they maneuver, I'll know that there's something here, something here, something here, and then nothing here. What it doesn't do is it doesn't tell the person what's in front of them. So if somebody walks up and waves, or if people are moving around, it conveys a very one-dimensional piece of information. And my hope is to extend that to maybe more of a two-dimensional array, so that I would know that you are here and that there's something next to you. Or that when I'm looking for a door, all the pins that would correspond to the wall would press up, but since the door is a hole, there would be nothing there. And so my attempt would be, in some ways, to add the second dimension to create something that's communicates more information, I guess, is what I'm going for. So essentially, to take something that somebody has already done, these glasses that can sense, but then just add more to it. Oh, does that answer your question?
So you think about having a sort of tablet that somebody can carry on?
Correct. Yeah. My hope would be something like a big cell phone, essentially. Something between the size of a current cell phone and this device that the gentleman had around his neck. Hopefully something in between. By seeing that device, it sort of gives me hope in the fact that it's battery operated, it is in some way maybe connected to a cell phone or other device. There's a possibility there's also these pads so they can do two-way communication. So I think it's linked to a cell phone so you can do SMS. But my hope would be something roughly in that form factor.
So how far away is the end product?
Well, I would say it's actually relatively close. In that the notion of a solenoid is well known, and the notion of applying electricity to these mechanisms that move up and down is also well known. So I'd be sort of writing on the fact that other people have documented these and there are data sheets on them, so I don't have to do any learning in that respect. And I've already done all the computer vision piece of it, so it's more a matter of just sitting down in a lab and putting the two together. So yeah.
A lot of this about the perception is that you have a gradient. For example, in the Kinect you have a different gradient, but with the solenoid you have on and off, so you have a one distance showing. How do you think that will work in everyday life? Because as we move around, are you setting a distance 2 meters in front of that?
Yeah, so this is actually something that I've thought about quite a bit. On the one hand, I was thinking that there could be some sort of dial, and that dial you'd have basically in meter increments. Like I'm interested in things that are in the 1 meter, 2 meter, or 3 meter range, and that might relate to whether somebody's indoors or outdoors. That's just a theory I have, and I don't know if that's actually real, so I have to do user testing. But you raise a good point in that you are closer than that person who is closer than the wall. So how do you get this gradient? I think unfortunately, I don't know how to tackle that problem. And that's something that either I would have to do user testing to find out what other people think about it, or to sidestep it and not address it.
Also another thing, technical, but the Kinect uses a fair amount of computing power to get this depth perception and all this.
Correct.
Which usually means a computer, which means wearable device.
Yep.
Because a lot of this is that you can carry that around in your everyday life.
Correct.
How have you been thinking about that?
Okay, so that's actually a really good point. I've been looking at smaller computers, things like maybe gum sticks, or which are computers of like the form factor of about a deck of cards. And then I've also been looking at Beagle boards, which are also in the same form factor. I think the downside is that you would eventually have to have something maybe like 2 novel books worth of size. I'm not sure how much that is in centimeters because I'm from the US, but like two paperback novels put together would probably be the size of the device that's in somebody's backpack. And then you'd have to have some sort of cable or cord connected to the cameras for the Kinect. So it's not without its downsides, to be sure. Yeah, absolutely. Yeah.
One final question.
You mentioned user testing.
Yes.
Have you talked to anyone visually impaired or discussed the matter with them? Like trying it out somehow?
Yeah, so at the moment I haven't, but what I'm doing is for my final project for this year in class, I'm talking with people up at KTH in Stockholm, and they actually have a course that's around building haptic interfaces for people with disabilities, and my hope is to take this and to work with them in that way. Unfortunately, because of language barriers and what have you, I've had a difficult time finding people who would be willing to interact with me, but my hope is that through that contact at KTH and actually spending some time up in Stockholm, I might be able to address that issue.
So blind people don't want to speak English with you?
It's mostly a matter of finding institutes, finding people who I can go to and say, hi, I would like to discuss the possibility of making a device with blind people. I also don't speak Swedish. I'm a student with my own schedule, and would it be right if I like entered their home and find out what's their home environment like? So it kind of starts putting up some barriers. Yeah, so unfortunately I've found some stumbling blocks there, yes.
Thank you.
Thank you.
Very much.